up to this point, we've assumed that when atoms share electrons to form bonds, that those electrons are shared equally between the two atoms. And we make this assumption quite a bit. It's not necessarily true, and honestly, it's not true all that much. So what we need to do is come up with a way to determine how evenly those electrons are shared, and determine if that's going to affect the overall properties of that bond. Okay, so to do this, we're going to use this thing called electronegativity. And electronegativity is a property of an atom, or an element, I guess, of how strongly the atom pulls bonding electrons to itself. So for example, if I have two atoms that are bonded together, we'll call it atom 1 and atom 2. There's an electronegativity for each atom. And for atom 1, the electronegativity is how strongly it pulls the bonding electrons to it. And then for atom 2, the electronegativity is how strongly it pulls the bonding electrons to itself. Right? So it's like a competition almost between the two atoms on which one can pull the electrons towards it more. Now, the electrons are still shared, but they may spend more time near one atom than the other because of the electronegativity. And this will affect the properties of the bond and possibly the properties of the molecules that contain those bonds. Okay, so if we look at electronegativity, I've got a little table down here, and it shows the electronegativities of the main group elements. And we can see the nonmetals, the ones in the upper right corner, have the highest electronegativity, and the metals, the ones down the lower left corner, are going to have the lowest electronegativity. And this isn't surprising, because we know when ions form, the nonmetal atoms form anions, which are negative ions, which means they gain electrons, and the metal atoms make cations, they lose electrons. So we'd expect the nonmetal atoms to actually be able to draw electrons to them better than the metal ones, and we do. We can see that fluorine has the highest electronegativity at 4, and then the next highest is oxygen, and then chlorine and nitrogen, and so on. And as we move away from fluorine in any direction, the electronegativity goes down. So clearly, we can see trends in the periodic table, and this is going to be the case for most properties we look at the periodic table. There are going to be trends where the property changes systematically as we move across or up and down on the periodic table. So we can see that if we're moving in a family or a column or a group, whatever you want to call it, as we move down the periodic table, the electronegativity goes down. Right? So as we go from fluorine to chlorine to bromine to iodine, fluorine to chlorine to bromine to iodine, the electronegativity gets less and less. If we look at a row in the periodic table, and we start on the right side and move left, as we move away from the nonmetals, the electronegativity gets less. So fluorine, oxygen, nitrogen, carbon. As we move towards the metals, the electronegativity gets less. So that means as we move up and to the right, so kind of in this direction, the electronegativity increases. And we're going to look at properties like this where we're going to look at a trend based on the periodic table. And because the periodic table has a certain structure to it, and it's based on how the electrons are in the atoms, these trends are pretty common.